think about adding two vectors together. So here I've got one vector and another vector. I think there's going to be kind of two nice intuitive ways of thinking about this. If you imagine a vector as a movement, let's move over 2 and up 5. You could think about it this way. This is the movement represented by A. I'm moving over 2 and up 5, but sort of at the same time, this direction. And then the movement B says move over 3 and down 1. So that's the movement B. So if I want to add the two vectors together, you can think, what if I move along A and then I move along B? What motion would that be the same as? So if I move along A and then along B, that would be the same as if I just moved from here directly to there. So let's try and write down all the bits. Moving from here to there would be over 1, 2, 3, 4, 5. Maybe I'll write it. So over 5 and up 1, 2, 3, 4. So I know that A plus B should end up being 5, 4. And you'll see numerically it makes a lot of sense. A is 2, 5. B is 3, -1. And you can see that they've added component-wise. So the x and the x have added to make this x. And the y have added to make that y. It makes sense geometrically also. If I want to know how do I get all the way across to this point, let's think about moving horizontally and vertically separately. A has moved me over by 2, and then B has moved me over by another 3. So the 2 plus the 3 gives me the 5. Vertically as well, A moved me up by 5, but then B moved me down by 1, and the 5 minus the 1 gives me the 4. So everything kind of fits together. All right, why don't you decide, is A plus B actually the same thing as B plus A? Like, we know that's true with numbers. 1 plus 2 is the same thing as 2 plus 1. But vectors are totally different kinds of things, and so it might not be true. There are lots of mathematical objects where one thing plus the second thing isn't true in reverse. It's not the same as the first thing plus the second thing plus the first thing. So decide right now, decide it numerically, decide it graphically. Are these things the same? Hopefully you said yes. Here is A plus B. This side is supposed to represent B plus A. So I've got the same starting point, only instead of moving along A first and B second, I'm going to move along B first and A second. So see how B is over 3 down 1? So the first thing I did was move over 3 down 1, and then the second thing I did was move over 2 up 5. But you can see I still get the same resulting motion. This red arrow is the same in both cases. It's the same xy components. It's the same angle, same length. You could do it numerically this way. So we already know that A plus B is 5, 4. Let's do B plus A. So B is 3, -1. A is 2, 5. And again, if I add the x component separately and the y component separately, I do get the same thing. So here, let's notate this. B, A, and then this red arrow is B plus A. This red arrow is A plus B, but we know they're the same. Okay, let's think about it in a slightly different way, as combining forces. So let's put a dot right here, and let's imagine two forces acting on the same object. There's force 1 that's pulling it in one direction, and force 2 that's pulling it in another direction. If I imagine both forces happening at the same time, you can, well, why don't you do this? Why don't you actually use arrows to visualize what is force 1 and force 2 acting on this object, and then add them together to visualize the resulting force and think about how it makes sense. Okay, pause the video. And now I will do it. So force 1 is pulling over 2 up 1. So force 1 is pulling in this direction. Force 2 is pulling in this direction. So what happens if, so imagine this is like a person, and there are two ropes, and there are other people, like, pulling this way, and another person pulling that way. What is this person going to experience? What forces? Let's add them up, and we'll draw the arrow, and hopefully it'll make sense. We've got 2, 1 plus negative 2, 1. So if I add them up component-wise, the 2 and the opposite 2 make 0. The 1 and the 1 make 2. And so this is F1 plus F2. Okay, how does that make sense? Well, this person is pulling to the right, but this person is pulling to the left with an equal but opposite force. So the components that are pulling left and right are kind of canceling each other out. So this person doesn't feel like they're pulled left or right at all because they're balanced. But instead, they feel pulled up. And they feel pulled up by both components because this person is pulling them up a little bit, and this person is also pulling them up a little bit. So this would, in physics, this would be called the net force. So here are the two separate forces operating on the object, and that would be the net force. And this is sometimes called a free body diagram.